Assalamualaikum and good morning to Dr. Juan and to all our fellow friends. Today we would like to present to you about synthesis and characterization of a coordination complex of Tetrakis diphenylamine copper 2 sulfate hexahydrate. Before we start, let me introduce our group members, which consists of Sim Juni, me myself, Siti Mashita binti Muhammad Jan, Putri Farisa Balkis binti Erwan, and Reina Fang Yi Ching. This is our structure of the complex, which it is formed by copper complexes and diphenylamine. Now we move on to the background of the structure. For copper complexes, it can form many geometries with different types and number of ligands, which is square pyramidal, square planar, tetrahedron, octahedral, and also trigonal planar. For diphenylamine, it is a colorless solid, but it will form yellow solid when oxidized to impurities. Besides, it is a monodentate ligand, which it will donate one lone pair of electron on the nitrogen atom.
The main objective of this mini project are to synthesize and determine the characterization of the coordination complex of Tetrakis diphenylamine copper 2 sulfate hexahydrate. The first step is 10 ml of methanolic solution of copper 2 sulfate pentahydrate added dropwise to 20 ml of methanolic solution of diphenylamine. Next, constantly stir for 6 hours. After 6 hours of stirring, the solution was concentrated to 50 ml of volume. Next, the precipitate form was filtered with filter paper. The final step is dry the filter precipitate in desiccator for 24 hours.
So I would like to talk about the characterization of the complex form, and from the electronic spectra, hydrated copper sulfate has a maximum wavelength at 890 nanometer, while the copper 2 diphenylamine shows a wide absorption at 593 nanometer. Secondly, using atomic absorption spectrometer, the copper content in complex copper 2 sulfate pentahydrate with diphenylamine was 6.43 plus minus 0.16%. The molar conductance values of the complex lie in 13.39 plus minus 0.10 SCM cube per mole, while the charge ratio of the cationic to anions is 1:1. This is the magnetic properties of the complex. The effective magnetic moment of the present copper 2 complex is 1.72 bm. Last of the process of characterization is infrared analysis. Secondary NH vibration of the ligand at 3406 and 3383 was shifted to lower frequencies at 3404 and 3381 upon complex formation, while aryl NH vibration of the ligand of 1319 is shifted to lower frequencies of 1317.
The first main findings is the electronic spectra. The shifting of the maximum wave number of copper 2 sulfate pentahydrate triggers smaller wavelengths in the copper 2 diphenylamine complex, as shown indicates the substitution of water molecules by diphenylamine. Electronic spectra of the copper 2 diphenylamine complex show a wide absorption at 593 nanometer, assigned to the transition from 2B1G to 2I1G. Next, for the analysis of the amount of copper with AAS, the copper content in the copper 2 diphenylamine complex was as shown. Therefore, the approximated formula for the complex was Tetrakis diphenylamine copper 2 sulfate hexahydrate. For the analysis of electrical conductivity, the sulfate ion is not coordinated to the center metal copper 2 ion, but only acts as an ion. The complex dissociates in the solution will produce ions as shown in the slide. Therefore, the proposed formula of the complex was confirmed to be Tetrakis diphenylamine copper 2 sulfate hexahydrate. For the infrared analysis, upon complex formation, there is a shifting of the secondary and aryl NH vibration from higher to lower frequencies as shown in the slide. This reveals the coordination of the amine nitrogen atom. There is no absorption band of OH was observed due to the overlapping of the NH and OH absorption band. Lastly, the magnetic properties. The copper 2 complex has 1 ampere electron, and the magnetic moment value of the copper 2 complex indicates that Tetrakis diphenylamine copper 2 sulfate hexahydrate was present in square planar geometry as shown in figure 4, which is coordinated by 4 NH groups of diphenylamine. Each atom will produce the same string of repulsion, and the distance and position of each atom is the same to achieve the least possible repulsion.
To conclude, hydrated Tetrakis diphenylamine copper 2 sulfate hexahydrate complex was able to be synthesized by mixing a metallic solution of copper 2 in a metallic solution of diphenylamine with a mole ratio of 1:4 and stirring for 6 hours. The complex form was paramagnetic, and the functional group coordinated to the copper 2 was possibly NH, forming square planar geometry.